All right, so when we look at this, hopefully we can see the geometry and set up the information used in the geometry. If I look at that line right there and that line right there, and let's use that transversal first. Okay, do we agree that that angle there and that angle there, there's a relationship between them?
Yeah. I think was 2x and then x minus y, was that the same angle?
No, they're separate.
Okay.
Because this one's got a degree symbol on it and that one's got a degree symbol on it, so they got to be different. So they're the same, right?
Yes.
So x minus 1 should equal 30. Okay? And that's all we can gain from that transversal. If we want these two lines to be parallel, that's what we're trying to do here, trying to force element to be parallel, those two angles have to be congruent. Okay? But likewise, what should you find out about, again, using that parallel line, that transversal, what is the relationship between those two angles? They're alternate interior, so they should be equal. Okay, so I should have 2x equals 5y, right?
Yeah.
Okay. Now there's a couple different things you could do here. Yeah, I think maybe, I looked at it and I started thinking about routes to take. You could do elimination. Okay. And a step of elimination here is going to maybe confuse some people and they forget to do it. Okay, because of a number that shows up. But we could also do substitution. That might be actually a little bit easier. Right? It doesn't matter which route we go. Just choose one that you're comfortable with. Okay. If I were to do elimination, let's go that route first. Okay. They both equations need to be written so that x and y are on the same side, right? Yeah. So let's take this one here. And what do I need to do so that x and y show up on the same side? Minus 5y. So I get 2x minus 5y, right? Subtract 5y from both sides. What would that leave me? Yes, it leaves me 0 over here. And a lot of times, when people don't get these right, or they get stuck and they say, I don't know what to do, it's because when they move this over, they forget that 0 is a very valid number. It's actually one of the most important numbers. Okay? So it's perfectly fine to have that 0 there. So now I've got these things. So I've got those two equations set up. I've got my x's on top of my x's, my y's on top of my y's, and my constants of 30 and 0 on top of one another. I would like to add straight down, correct?
Yeah.
But I can't, right? Because they don't cancel out right away, right? So what do I need to do?
Multiply the top one by -2.
Okay, so multiply top one by -2, and that's going to put a negative 2x there, a positive 2y there, right? Mm-hmm. And then a negative 60 there. And now we can add straight down because now your x's disappear. You get negative 3y equals negative 60. Adding straight down every column. So then y's got to be 20. Okay. Well, if y is 20, can I plug that back in over here?
Yeah.
And if I got 2x is equal to now 100, once I plug that in, 2x is equal to 100, x has got to be 50. Okay? So that's one way. That's using elimination. Now there's other ways of solving that using elimination still. We could have canceled the y's. Okay? I could have multiplied the top by negative 5 and canceled the y's. Does that make sense? Okay? So there's other approaches using elimination. So let's go back and maybe use substitution. Would you guys agree that using this green equation, that x is going to be the same thing as 30 plus y? So now can I take that? Oh, look at that route. X is equal to 30 plus y. Can I take that 30 plus y and put in for that x right there? So now I have 2 times 30 plus y is equal to 5y. So 60 plus y equals 5y.
No,
2y, yep. Subtract 2y. And then y is still 20. And then I can plug back in. Now, y was 20. Can I still plug back up into this equation and solve for x? Could I plug back up into that equation and solve for x?
Yeah.
Okay. So you would have alternative routes to go with the algebra, but we have to use the geometry to set that up. Okay. I'm assuming that we probably want to talk about the next one too, right? Was that 11? Shut up.
Well, sir. I got that answer right.
You did?
No. I just guessed, and I got it right.
All right. So what's the relation between those two angles?
Same side.
Same side interior. So if the lines are we're going to force these lines to be parallel, what's the relationship they have to be?
A equal 180.
Supplementary. I have to add 180. So x squared plus 3x needs to equal 180, right? Okay. When we see a power of 2, what algebra should you think about automatically? Okay, it is x squared doesn't mean x times x, but factoring.
Yeah.
Factoring is what we want to think about. Every time you see something to the second power, and eventually when it becomes the third power, fourth power in other classes, you want to think factoring. So once I think that, the number one thing about factoring is that you have to have things equal to what number? 0. So I know I'm going to factor. Now I need to adjust this equation so that side becomes 0. So the way I do that is I subtract 180 from both sides, right? Okay. So now, kind of show you a little trick here for factoring. Because with factoring, we want to think about two numbers that multiply together to give me negative 180 and add up to give me 3, right? Okay. And you can start listing your factors of negative 180, okay? 1 and 180, 2 and 90, okay? 3 and 60. You keep going and listing all those, right? But the bigger that 180 is, the longer that list is most likely going to be. So when I know, and this can happen a lot, okay? You can do this as long as this is a minus sign and that's a plus sign, or this is a plus sign and that's a minus sign. This will work. This number here is relatively small. Would you agree with that?
Yeah.
Okay. So what that tells me is that the two factors that we're using here to multiply together to get me negative 180 have to be pretty close together. Okay. For instance, let's do this. What is, if I look at 180, what numbers do you know automatically multiply together to give you 180? Because it ends in a 0, you know 10 and what?
9.
10 and 18. Okay? Now, I'm going to make the 10 negative. Now, listen, I'm going to make 10 negative. Okay? Now, obviously, those don't add up to give me 3, right?
Yeah.
Okay? These two values over here are 8 units. If I just look at their absolute value, they're 8 units apart from one another, correct?
Yeah.
Okay? So that would mean that this would be an 8 here instead of a 3. Let's alter those. Let's move one of these down and the other one up. Okay? So let's say that I go negative 12 here and 15 there. Okay? Now, I don't know if those multiply together to give me negative 180, but I do know that they add up to 3, right? Does that kind of make sense? And they're in the same kind of ballpark that 10 and 18 were. Well, if I multiply negative 12 and 15 together, what do they give me? They do give me the negative 180. Okay? So I'll show you maybe a quicker way to do that here in a moment. So I'm going to go x minus 12 and x plus 15 is equal to 0. Okay? Now, what I want you to understand is that these two statements say the exact same thing. Just the blue one is a better way of seeing it. Okay? If I see that blue one, that means FOIL, right? Yeah, binomial comes to binomial. If I FOIL that blue one out, it gives me exactly what the red one says. Okay? So they're the same thing. This one's just a better way of looking at it, because this one now tells us, instead of looking at a sum of 3 things, we're looking at a product of 2 binomials. And those binomials are becoming, when I know what x is, they're numbers, right? Okay, so yeah, number times a number is equal to 0. So it tells me something about those numbers right now. Up in this format, I don't have that relationship. Okay? If I have 2 numbers 2 numbers multiplied together and they equal 0, what does one of them have to be? Now, careful. If I have a number here, make sure we're answering the question I'm asking. If I have a number times a number and I get 0, what does one of these numbers have to be?
0.
0. Okay? Or both of them could be 0, right? That's why we do both. Okay? So what we do is we say that this number, which is represented by x minus 12, has to be 0. and this one is x plus 15 has to equal 0. Okay? Now, the reason we go and rewrite it this way, instead of the way it was written in red, is because this way in blue allows us to make the distinction of what should be equal to 0. In red, you look at that in red, and you can't say, well, I know x minus 12 should be 0, right? You can't see that. So you have to factor to get down to this. So x is 12, and x is negative 15, right? Okay. Now remember, the algebra we just did has no understanding, no recollection that it came from a geometric picture. Doesn't know there's any context to it. Okay. So every time you do one of these, you're going to get answers like that. You're going to get two answers when you factor. Okay. We need to make sure that they work for our problem. If I plug 12 in, what's 3 times 12? 36. Is 36 an okay number for an angle?
Yeah.
Okay. What's 12 squared?
122, 144.
We'll go 144. Is 144 an okay measurement for an angle?
Yeah.
Add those together, what do you get? 180. Okay. Now, let's take the negative 15. Negative 15 squared is?
20, okay, that big number.
225. 15 squared is 225. It's positive, right? So that's okay, but do we have angles? Have we talked about angles right now that have been bigger than 180? So that instantly should tell you you've got an issue here with this negative 15. Okay? If I plug it in here, I get an even bigger issue, an angle of negative 45 degrees. Okay? Which eventually we'll talk about negative angles. Okay? But right now we don't have the ability to do that. They still add up to 180, right? 225 minus 45 gives me 180. But they violate the definitions that we have set up so far for angle measurements. Okay? So, for this picture, this number violates some geometric rules, so that number cannot be an answer. Does that make sense?
Yes.
And that you have to check those. You can't just say, I'll choose the positive one, or I'll choose the negative one, or something like that. Or when 12 works, I'll get rid of the other one. Okay? You always have to check both. And the fact that one works doesn't mean the other one will or won't. Okay? We saw last week, we did one of the previous worksheet where you got x equal 5 and x equal negative 5. And they both work. Okay? So make sure that you go through and you check both solutions. Now, going back to the factoring technique here, that I always use, if I find out that that number right there is relatively small, I don't like to sit down and list all my factors because it's just too time consuming. So if I know that middle number is relatively small, I need a starting point. So what I do is I take the 180, take my calculator, go 180, and I take the square root of it. Okay? So if you use square root function, or you can do it that way, raise it to a 1/2 power. And I get 13. Okay? 13.4, right? So that's my starting point. I'm going to take 180, and I'm going to divide it by a whole number that is really close to 13.4. So I either try 13 or I try 14, and I'm going to see if I get a whole number back. I don't. Okay? So I'm going to go 180, and then I'll divide it by, maybe I go to 14. Didn't get a whole number back. Then I go 180, and I divide by 15. And I get my whole number back, and there's that other factor. Does that kind of make sense? Okay. That only works when this number is relatively small. Okay. And the smaller that number is, the quicker you're going to come about, dividing by those successive integers to get that 3. It only took us like 2 or 3 to divide out. Even if that number was like 8. Okay. I'm probably going to take 180, square root it, get 13. But now I got to kind of move quite a ways away from that 13 to get that other factor. But that is a process that will work all the time. It gives you a starting point, okay? And I think that should maybe allow you to be a little bit more efficient. Some people say, how do I get better at factoring? All right, so again, we're trying to force lines to be parallel, right?
Yeah.
So let's use colors. We've got those red lines. We want to force those to be parallel, and then these blue ones, we're going to force those to be parallel, right?
Yeah.
Okay. So what I'm going to do, I'm just going to look at the red ones real quick. Okay. Look at the red ones in that blue transversal. What relation can you make instantly? The red lines, well, we want them to be parallel. Okay, but what do the 3x and 105 have to be if the red lines are going to be parallel? They have to be equal. They're alternate interior. So let's say 3x equals 105, so x would be 35, right? Okay. So x is 35, so that's nice. I now know that this angle here is 105. I now know this angle down here is 35, right?
How? Why?
Because it's x.
Oh, no.
Same.
I was gonna say what I did.
What'd you do?
I did, okay, so the top of the other triangle where D is, that, that's 105. So I did 35 plus 105 plus 2y equals 180.
Okay, so what she's saying is if we look at those parallel lines, the blue lines being parallel, we want them to be parallel. We don't know them yet, but we're trying to force it. So if they're going to be parallel, she's saying that angle there and that angle there have to be alternate interior, right? So she transitions that 105. Okay. And now you said that 105 plus 2y plus this 35 should equal 180, right? And were you looking at the fact of because it's trying? Correct. Okay. So using a fact, maybe we haven't talked about it yet, but we do know maybe from 7th grade, 8th grade, we mentioned it maybe once or twice previously that you can do that. That's fine. It works. So I got 140 plus 2y is equal to 180. 2y will equal 40. Y then ends up being 20, right? That works 100% of the time. Okay. However, we should still be able to do this problem without having to know anything about triangles. We haven't talked about them yet. Okay. So let's do this. Let's say that I had those two lines, those two blue lines. We want those to be parallel, right?
Yeah.
A transversal that people overlook is that one right there. What is the relation between that angle there and that angle there? They're corresponding, and that means they're congruent, right?
Yeah.
So now, what do you know about that angle plus that angle plus that angle? They should have to 180 as well, right? And that gives you the exact same equation Emily got us, okay? But using something that, or a fact that we've talked about in disregard to the triangle effect. Does that kind of make sense?
Yeah.
All right, so either one of those routes is fine. Would those three angles be supplementary?
No.
Why not?
Because there's 3, not 2.
Good. What's Tyler? What's angle D supposed? That's 105 up there.
Size horrible 1 of 5.
Oh my God, he is. All right, let's for time's sake talk about the